So focus today is performance meets automation. And I'm going to talk about like 5 autonomous features that we have introduced to deliver accelerated performance without putting any overhead on the teams managing performance. Okay? And the features that I'm going to talk about are result cache, autonomous reflection, clustering, optimization, and C3 cache. All of these features have one thing in common. They are autonomous. That means no tuning is required to take advantage of these features. And, so let's get started. The world of analytics has fundamentally changed, right? And we have AI agents and applications that have transformed how we interact with data. A lot of work that is being done, like MCP server, connecting LLM models to your enterprise systems or RAG applications, all of that is running in your data lakehouse. Now, one thing that is changed is because of AI, the workloads have become a lot more dynamic, and it's not really scalable to manually tune performance to accelerate those workloads. So the focus today is, really accelerate AI workloads as well as BI workloads using autonomous feature. And the first feature that I'm going to talk about is result cache, right? A lot of times you have the same query running over and over on a data set that has not changed. Now, if we keep executing this query, that is pretty much redundant execution. It takes a lot of time, and you could be wasting a lot of compute and also cost. Oh. Sorry. Okay, so if you get the same query that is executing again and again on a data that has not changed, you could be wasting compute. You could be like slowing down response of those queries, as well as it results in poor scalability, right? So that's exactly when result cache can help. And with result cache, we are not re-executing query, resulting in no redundant computations. You get instant result, and it's automatically managed and scaled for you. Okay. Now, how this works is, as query comes in, query planner, tries to match the input query in the saved result cache and saved result cache list. Okay. And if it finds a match, then it pretty much fetches the result that it has cached and returns the result, delivering in sub-second response time, and without re-executing the query. But if it does not find a match, then it executes query normally and then stores the result for future reuse. Oops. Okay. So result cache entries are, if we find that if we execute a query and if the result is less than 20 MB, then only those queries get cached, and they get cached in the project store or distributed store automatically. Is there echo? Okay, so it's only cached for select queries that are on Iceberg, Uniform, Parquet, and Reflections, because we really want to see if the underlying data has changed. And if underlying data has changed, or a schema has changed, or a reflection materialization has changed, Dremio will automatically invalidate the result cache entry for you. Similarly, any cache entry that has not been not been leveraged in the last 24 hours get removed to free up space on S3 bucket where we are storing it. So the maximum time unused cache could stay in your bucket is 24 hours. Now, one data point that I wanted to share here is we have Dremio Cloud, and we are looking at some of the queries coming in from different customers in Dremio Cloud. And we find that 30% of queries that come in get accelerated by result cache today, right? Which is a big win. And if you are running TPC DS, which on a 1 terabyte scale could take few minutes, with result cache could run in less than 30 seconds. Now, I'm not saying that that's like a benchmark that we want to talk about, but what it tells you is, what's the value of result cache in accelerating queries if you get repeat queries. Okay? Any questions? We can make it interactive. This is a pretty small group. Yeah, okay. So, okay. So we have looked at result cache, which was an easy win. If you have identical queries, we can pretty much cache the result and reuse it in future accelerating queries, right? Now, it is not that we will always have queries that are identical. There will be queries that are not necessarily identical, but they have identical patterns inside them that could be accelerated, right? So imagine you can have a query that is on a specific data product, or that is, queries that are sharing joins, or queries that have common aggregation between them, though the end result could be different. To accelerate those queries, that's the next feature that I'm going to talk about, which is autonomous reflection. Okay? Now, before we get to autonomous reflection, let's look at what are reflections in Dremio. Reflections are key feature in Dremio's query acceleration toolkit, right? And we think of them as a relational cache. And why I'm saying relational cache is it's a combination of a query plan and a materialization to go with the query plan that acts as a building block, right, and leveraged by optimizer to accelerate queries. Now, I want you to focus here on transparently, because as an end user who is running queries, you are not aware of reflections. You are running queries against tables and views that you are familiar with. And Dremio Optimizer will automatically, use reflections in your query plans to accelerate your queries. Okay? Now, reflections are pretty powerful, but until recently, reflections had to be manually created and managed in Dremio. Now, that's exactly the part that autonomous reflection addresses. So over the last, few years, I talked to a lot of customers that have leveraged reflections, and some of those that have not leveraged reflections. And there was something that was a common theme that we heard from many customers. We often heard from customers that creating reflections manually and managing them was not easy, right? And they wanted some help from Dremio on that front. Similarly, you could create a reflection to accelerate a specific query patterns, but then your query patterns could change, so it requires constant maintenance of reflections. Now, other thing that I often heard is we are worried about reflection providing us the stale data. How can we guarantee that reflections are always going to deliver fresh and current data all the time? And last but not the least is oftentimes the consumers don't have access to create reflections. They depend on data engineering teams or the teams that are managing performance to create reflections. And that often creates a bottleneck because the teams managing performance could be busy, and that delays time to insight. And so we often thought, like, why not create reflections automatically based on user workloads and manage them automatically, delivering seamless user experience and a performance that customers expect, right? And we delivered that with autonomous reflections. So now what happens in autonomous reflections is Dremio automatically creates reflections for your workloads based on the query patterns that it sees in the last 7 days, okay? Once these reflections are created, they are also maintained or updated as the underlying data changes automatically. Not just update, but we also ensure that you will always get the same result with or without reflection by only leveraging reflections that are up to date or that are in sync with its underlying data. So we are creating reflections, we are updating them, and we are also guaranteeing freshness by only leveraging reflections that are fully up to date, right? So that guarantees that we are never going to give you stale data from autonomous reflections, but we are only going to, accelerate whenever possible. The last but not the least is now the consumers don't depend on the data, the teams that are managing performance to create reflections, because Dremio is creating reflections based on the user workloads. Okay, so how this works is you have different tools and agents connecting to Dremio running queries. These queries could come from like BI tools or agents like Dremio agent. And Dremio will automatically learn from the usage patterns of users and then create reflections. And these reflections will automatically be used by Dremio Optimizer to accelerate user workloads. So, and what you have is fast performance without any work being done, by users manually to accelerate queries. So you would have seen this picture a few times before, but what happens here is as you run queries, for every query that you run, Dremio asynchronously collects some metadata about queries, and this metadata is used to figure out patterns. and these patterns are processed every night to come up with recommendations. The recommendations for reflections then get scored based on the return value that each recommendation can generate. And similarly, the existing reflections that Dremio has automatically created get scored based on the value that they produce. And so now I have two scored lists. These two lists are then used to make a decision on what reflection should be created and dropped. Once the decision is made, the reflections are either created and dropped, and then these reflections are automatically maintained as the underlying data set changes, and they get used to accelerate queries. And then when we go back here, again, the new data is collected, and this cycle continues. It runs every day to create reflections or remove reflections that have a lower return on investment because of changes in workload patterns. Okay. Oh, sorry. Okay. So few things to note here is we are in this phase only creating reflections on Iceberg, Parquet, and uniform data sets, and we are using 7 days history to create reflections. Okay. So if you are using Dremio Cloud, which is just released today, autonomous reflection is on by default. So if you start running queries, next day you may see some autonomously created reflections that could accelerate queries from the previous day. But if you are running Dremio software, this feature is available, and you can enable this feature through preference page. Okay. Now, again, I'm coming back to TPC-DS. If you are running TPC-DS 1 terabyte workload, and you run it over and over, autonomous reflections could identify a pattern and then accelerate your TPC-DS queries, all 100 of them, and you could have a TPC-DS run within 30 seconds. Okay. So that's about autonomous reflections. Before we go into the clustering, anybody has questions on autonomous reflections? Yeah.
So you mentioned that it's automatically generated based on like the past 7 days. Is there any way to like configure to have like some rules set for the way it generates reflections?
So in the first phase that we released, which is in version 26.0, right? We have not provided a lot of levers, but there are a lot of checks and there are a lot of checks put in to make sure that we are not creating reflections if you don't need to. The goal is to not create reflections. So like, for example, you were mentioning that I have manually created reflections, all my dashboards are flying, everything is good. Dremio may figure out that I don't need to create any reflection. Okay? So because what happens is, as you run queries, we collect some metadata. That metadata is used to figure out patterns, and we may generate a recommendation to accelerate a pattern. Now that recommendation is used to plan a query, and we may find that with existing reflections, I'm not choosing the new reflection, or if I'm choosing the new reflection, the cost difference between existing reflection and new reflection is not much. Dremio will just ignore the recommendation. Okay? So there are a lot of guardrails in place to make sure that any recommendation or reflection that we create is going to get you a high return on investment. If it is not going to be there, Dremio will not create a new autonomous reflection. Okay? Similarly, if we created a reflection, but the usage pattern changed, and we now find that the reflection that Dremio has created is not getting used by queries, we may go and eliminate the reflection that we have created. So if everything is going well, you are manually creating a reflection, it should not impact you.
Okay.
Right?
Thank you.
But if you are like, oh, I don't know how to deal with reflections, I need help, or I want Dremio to manage these reflections for me, then this is a feature for you. And we have all types of customers. Any question? Okay. So we have looked at the two different, we have looked at like, two ways to accelerate queries. One is to accelerate identical queries. The other one is to accelerate queries that share identical patterns. But there is one fundamental, thing that we need to look at is how data is organized on disk, because not all queries are going to be accelerated by either result cache or reflection. There will be many times your queries will directly hit the table, right? And if your data is not organized properly on disk, your queries could result in full table scans, and that could, be impacting the performance. So how to deal with that, right? And so before I get into, and so clustering is what I'm going to talk about. That's the third feature. But before I talk about clustering, I want to talk about like historically what were our options, right? The first thing is non-partition table. That means you just create a table without putting partitioning. Clustering is like simple, easy to create. You don't have to do any guesswork. You don't need to know about your data. You don't need to know about your query patterns. It's the best and easiest way to start. If you have a time series data and your queries are temporal queries, you may be good with not partitioning table as long as the size of your table is small. But once you get to certain size and your users start writing queries, on other columns like product IDs and stuff like that, you may find that non-partition tables don't perform well because you are doing a full table scan. Okay? And traditionally, we have tried to solve that with, Okay, so traditionally we have tried to solve this with partitioning. Partitioning is very powerful. It's been used for, decades. And, it's powerful, but it's complex. You need to know a lot about your data, your query patterns to make the right decision. You need to know, should I be using fine-grained partitioning? Should I be using coarse-grained partitioning? I was recently talking to one customer, and they wanted to partition on the product ID. And they found that, if I do a partitioning on product ID, I could accelerate queries. But then they realized that their ingestion was impacted because we were sorting data as the data came in, because with partitioning, you need to segregate and sort and segregate data, because the data gets written by, each partition gets written in a separate file, right? And so what ended up happening for them is every load started creating thousands of files, right? So then they decided, okay, we should do bucketing. The next question then was, what should be my bucket size? Should I go small or should I go big? And so with a coarse-grained bucketing, you could solve few problems, but you could have like data skews. Some buckets could be very big, some buckets could be very small, right? And if you go with fine-grained partition, like lots of buckets, again, the same problem as too many files could show up. Now, is there, again, and the other problem that this customer faced is that ingestions were impacted because we were sorting the entire data to create partitions and segregate partitions in different files. Is there a better option? And the option that we have in Dremio today is Iceberg clustering. Okay? Now, with Iceberg clustering, you get the partition-like performance, right? Without any trade-off on ingestion, because we are not necessarily segregating data based on the partition key. Now, in this example, if you see we have clustered this table based on date and item. And here, this is a file that has data for 424, 425, as well as different items. But the idea is you want to co-locate data that is related to each other in files, right, with clustering. So if all you need to do with clustering is you are defining your keys that you need to provide, that you use for filtering, and as soon as you define and put it on the table, if you are in Dremio Cloud, we automatically maintain the partition for you. If you are in Dremio software, you will run optimize table to cluster, your table. Okay? Okay, so clustering uses z-ordering. With z-ordering, you are co-locating identical data. It basically could use more than one column. It takes multiple dimensions and maps it to a single value, and that value is then used to order your data such that the related data is co-located next to each other. Now, imagine like if this is your input files, and we have five files here. File 1 has no overlap. Okay, and then file 2 is overlapping with file 3. File 3 is overlapping with 4, 5, and 2. Right, so there is an overlap, and let's say if Dremio decides to cluster this, table that has some overlap, right? How we would approach this? One output of, after applying cluster, one output that we could get is a single clustered file. The other output we could get is 2 clustered files where the size of the file that we are writing exceeds 128 MB, we may write another file. But sometimes what may happen is there is a region of files where there is a lot of overlap, and all the files together are big enough in size that we don't want the entire operation to be done in a single iteration. So we may split it into 2 iterations, and we may take file 1 and 2 and then cluster them as cluster group 1, file 1, cluster group 1, file 2, and then take the other 2 files and then, cluster them separately. Now, after we do this, or if our goal is to get no overlap, then as you can see, there is an overlap between cluster group file 1, group 1 file 2 and cluster group 2 file 1. Now, if I want to eliminate this, I can go for second iteration and then do another round of clustering to get data organized such that there is no overlap. Now you may feel like there is overlap here, but they share the same value, and it is sometimes possible that the same value for the index generated by Z order could be present in two different files because of the file size limitation, right? But we don't consider this as overlap because it's just overlap on a single value. Okay? So any question on clustering? Okay, so the next capability that I'm going to talk about is optimization. Even after clustering, you may have tables that have like some issues, and the issues could be like you have too many small files, and that could be because of ingestion. As you start ingesting data, the small files could accumulate in your tables, and as the small files start accumulating, your query performance could suffer. If you are doing lots of updates and deletes, because we do merge on read, we don't remove deleted records from the file immediately. We leave them in the table and just mark deleted records, which has performance impact when we are reading the data out, because those records have to be filtered. As you do a lot of operations, your metadata could be consolidated. I mean, metadata sizes could grow, which can impact planning. We could consolidate that. If you change your partitioning scheme, for example, if you had data in the table before, that data will not adhere to the new scheme. And if you want the old data to adhere to the new scheme, you may want to, again, optimize or reorganize your table. And last but not the least is clustering. If you have defined clustering on your table, Dremio can automatically figure out if there are regions of your table that have degraded degraded clustering, and then go fix it. Now, all of these operations is done by Optimize. Again, Optimize is introduced and available in the product today. What we have done, which will be part of the release that went out today, is we have made it a lot more efficient. So if you have like a lot of partitions, historically it took us a lot of time to process partitions that didn't actually need any reorganization. We have optimized that, and we can now pretty quickly identify from list of partitions in your table. We can quickly figure out which partition has data that needs to be optimized and only focus on a specific partition in a very large table. This is a new feature that is going out in 26.1. And as you can see here, we have cut down time on table 1 that didn't need any optimization. We were spending 43 minutes on it just to figure out. We are now doing the same operation in 3 seconds. Table 2 had only one partition that needed some work. We can do it in 8 seconds. And that's the difference, and this is like the memory requirement. Earlier was 1.85 GB, and now it is 13 MB. This optimization of optimize command is going in version 26.1. Okay, and also available in Dremio Cloud. Okay, the last one is Columnar Cloud Cache. This is really not a new feature. It has been in the product for a while, but the idea here is to really help with cloud storage latency, right? So if all our queries have to hit object store, cloud object stores, there will be a latency and which can impact performance. Now, Dremio with its Columnar Cloud Cache, right, can really accelerate performance by really caching hot data close to compute. So instead of like really going to object store for queries, it can cache hot data that is used often, local to the disk, and use it often, and then remove data from the local store, that is not frequently accessed out automatically without you having to do anything. So this feature is available for Parquet dataset. Because the local stores are relatively smaller in sizes as compared to object stores, instead of caching the entire file, Dremio caches blocks of files, the chunks of 1 MBs, and it also uses affinity-based routing. That means the executors that are processing that block is the executor that has the block, okay? This helps in really, maximizing cache benefit, right? Now, also with LRU, it identifies, for eviction, it identifies the data set that are least frequently used, and inside the data set, it identifies the blocks that are least recently used and eliminates them. Okay. Now, this is again a feature that you may not have to worry about because this is again seamless. You don't need to set it, or you don't need to do any configuration other than setting the size of your local store. Dremio will, do its best to deliver good performance. Okay, so before I end, we have looked at some of the autonomous capabilities. We have looked at, accelerating repeated queries with result cache. We have looked at accelerating query sharing identical patterns with autonomous reflection. We have auto clustering to, help with data optimization, data organizations. We have optimizations to maintain good health and performance of Iceberg tables. And we talked about C3 cache to deal with cloud storage bottleneck, right? All of these are very powerful features, but the best part is all of these are seamless. Don't need any configuration, and you don't need to do any setups, right? And that's what we call as, performance meets automation. And, our goal is to do more, and as we kind of work on more autonomous features for accelerating performance, so these are like the 5 features that are already part of 26 version that was released earlier this year, and also available in Dremio Cloud.